Hey, it's Miss Miklos with our Chapter 3 review video. So in this video, we're going to cover a little bit of everything. Most of the problems I'm going through are straight off of the review worksheet, but there are a few that I've added on for myself. So just kind of to review the order that we're looking at stuff. This gives a quick outline of the concepts we're going to cover. Graphing, there's really three aspects of graphing. Graphing systems and then graphing linear inequalities. There's also going to be a problem where we need to read the graph and write the equations of the system and then solve it. Okay, we're going to cover our algebraic methods, which would be substitution and linear combination. We're going to cover Cramer's rule. We're going to talk about how to write systems, and that was on your group quiz last time. Hybrid, I don't know if we took that group quiz or not, but my other classes did. And then lastly, our favorite, our word problem. So we're going to start with number 1, and on the test it will be similar to this, where we need to go ahead and follow the directions, where it specifically is going to tell us how to solve this. So this is specifically telling me to graph. So our first line, my slope is the opposite of a over b, which is positive 1. My y-intercept is c over b, or negative 4. So I'm going to go ahead and graph that. I know negative 4 is like an ordered pair of 0, negative 4. And I'm going to go up 1 and over 1. Okay, so there's my line. My second equation, my slope is the opposite of a over b, or negative 3. My y-intercept is 0 over b, which is 0. So this is telling me I'm going to go down 3 and over 1. Okay, and I'm going to try and draw that line accurately. Remember, when we are graphing, it is important that we're accurate here because we're trying to look for the point of intersection. And here, it does look like we have an ordered pair of 1, negative 3. I'm thinking that's my answer, but let's double check. We know the way that we double check is by substituting it into both of these equations. On the test, I would definitely do this. So the first one, I would get 1 minus negative 3, which is 4, so that works. 3 times 1 plus negative 3 is 0, which also works. Okay, so graphing, we definitely just need to take our time, find the slope, find the y-intercept, graph accurately, and double check our ordered pair by substituting it in for x and y. Now we're going to look at number 4 on the review, and you might be thinking, that doesn't look like number 4, but it actually does. This is just written slightly differently, and I would expect to see something like this on our test. So the first thing I'm going to do, I know that I can split this up by forgetting about the right side and just focusing on the middle and the left. And then our second inequality would be forgetting about the left side and just focusing on the middle and the right. Okay, so these look kind of weird. I would probably rearrange this. I'm going to put x and y on the same side. There we go. Okay, so my first line here, which this one is pretty tough. Okay, so we're going to go with this line. My slope is the opposite of a over b, which is positive 1/2. My y-intercept is c over b, or negative 1/2. So I'm going to begin at negative 1/2. I know my slope is 1 over 2. Okay, so I'm going to just kind of draw that. And I know that my line has to be dashed. The reason why I know it has to be dashed is because it just says less than. Now I need to figure out where to shade. Should I shade on the side of 0, 0, or on the opposite side? So I'm going to substitute in 0 minus 2 times 0 is less than 1. Is 0 less than 1? And that is a true statement. So I'm just going to draw like a little dashed line on that side to tell myself that's the side I would shade on. The reason why I'm choosing that side is because that's where 0, 0 was. Okay, my second line right here, I'm going to do y is less than or equal to x. So my slope is 1 and my y-intercept is 0 because that was already in slope-intercept form. So when I graph this, I'm going to begin at 0 and I'm going to go up 1 and over 1. Okay, and this line is going to be a solid line. Okay, the reason why I know this is solid is because it says less than or equal to. Let's double check. Let's choose an ordered pair. This time 0, 0 doesn't work because it's on the line. So I might try something like, let's see, let's write it up here. Let's try 0, 1. Okay, so if 0, 1 works, I know 0, 1's right there, so I would shade on this side. If it doesn't work, we would shade on that side. So when I plug 0, 1 in, I get 1 is less than or equal to 0, which is not true. So that means that I'm going to shade on the opposite side. So right now, if these were my only two lines, I would shade everything right in here. But we know we're not done because we have this third inequality. Okay, with this inequality, my slope is the opposite of a over b, so -1, and my y-intercept is 4. So I'm going to begin at 4 and go down 1 and over 1. I know my line is dashed because it just says less than. And this time, if I put 0, 0 in, if it works, I'm going to shade inside this little triangle. If it doesn't work, I'm going to shade over here. Okay, so let's test out 0, 0. Okay, I would get 0 plus 0 is less than 4, which is definitely a true statement. So that means that I'm shading on this side, which means this little triangle that's right in here is where all of our solutions are. Now, one thing we can do to check this, okay, it definitely looks like 1, 1 is is in that shaded region, and the reason why 1, 1 could be a solution is because it's on this line which is solid. So if I have 1, 1, let's just plug it into all three inequalities. Okay, here I would get 1 minus 2, which is -1, is less than 1. That works. When I substitute in here, I get 1 is less than or equal to 1. That is true. Here I get 1 plus 1 is less than 4. 2 is less than 4. So that is a true statement. So a good way to double check our graphing inequalities is to choose an ordered pair from where we shade, substitute it into all of the inequalities to make sure it is a solution. Okay, I wanted to go through this. This was on our review as well. But sometimes I think that looking at these, yeah, we can see that our solution appears to be at -1, 2, 3, -3, 1. But I'm not positive, okay? And the problem here is we don't have equations, so I need to write these two equations. I would not be surprised if the one on your test, if the solution is actually fractional, and we need to double check by writing equations. So I'm going to think of this as equation number 1. So if I'm looking at that, I can look and see that my slope appears as if it's going up 1, 2, 3 over 1, 2, 3, 4, based on the ordered pairs that are given to me. So up 3 over 4. And I'm going to use this ordered pair of 1, 4, and I'm going to use slope-intercept, or point-slope form. So I'm going to do y minus 4 equals 3/4 times x minus 1. So I'm going to distribute 3/4 minus 3/4. When I add 4, I get y equals, there, I forgot the x there, y equals 3/4 x. 3/4 plus 4 would be plus 13 over 4. I could also write that as a decimal if I wanted to, because divided by 4 will give me an exact decimal. So that is one of our equations. My second equation here, so equation number 2, this one I think is actually a little bit easier because I can see right away that -5 is my y-intercept. Okay, if I'm trying to figure out the slope, it appears as if it's going down 2 to the right one, down 2 to the right one. So my slope is going to be -2. Now the next thing it's going to ask me to do, so this is step 1, is writing those two equations. Now it's going to ask me to solve this system using a different algebraic method. So I just went ahead and rewrote them up top here. And I'm going to go ahead and use substitution because I noticed that both of them are actually already isolated for y. So I can write 3/4 x plus 13/4 equals -2x minus 5. Okay, I might decide to multiply everything by 4 to get rid of my fractions. So I have 3x plus 13 equals -8x minus 20. So now if I'm combining my like terms, I would get 11x equals -33, so x equals -3. Now to find my y value, I can substitute into either one. Of course, I'm not going to choose the one with the fractions. I'm choosing the other one, which looks much simpler. So I get 6 minus 5, which is 1, which gives us a solution of -3, 1. Now, I can see on my graph, -3, 1 looks like that would be the solution. Okay, but I also used a different method in order to solve it. Now, if I really wanted to use a different method here, I could have, but I think substitution is hands down the easiest method to use there. So our next section just says use an algebraic method, and we know our two algebraic methods are linear combination and substitution. I think either method would be equally easy here. Let's go ahead and use substitution just to kind of model that. So I think hands down this is the easiest variable to isolate because it has a coefficient of 1. So I get y is equal to 47 minus 5x. So when I'm substituting that in, okay, I have 6x minus 5 times 47 minus 5x equals 13. And when I distribute, I get 6x minus 235 plus 25x. So that gives me 31x minus 235 equals 13. 31x equals, when I add 235 to both sides, I end up getting 248. And when I divide both sides by 31, I get x equals 8. So now I need to figure out what my y value is. 47 minus 5 times 8. So y equals 47 minus 40. So y is equal to 7. So that gives me an ordered pair of 8, 7. Now, you also could have very easily used linear combination on this, and we would get the same answer. Let's just double check real quickly. When I substitute into the first one, I get 48 minus 35 is 13. That works. 40 plus 7 is 47. That also works. Since we used substitution last time, I'm going to use linear combination on this problem. And linear combination, remember my goal is to get my x's or my y's to cancel out. I'm going to choose to multiply this top equation by 2, and that is going to cancel out my y values. Okay, so when I add these together, I get 9x equals 18, so x is equal to 2. So now I'm going to substitute into one of those two equations. I'm going to use the first one, but it does not matter. So I get 8 plus y equals 5, so y is equal to -3. So 2, -3 appears to be my solution, but let's just check. 8 minus 3 is 5. That works. 2 plus 6 is 8. That also works. So 2, -3 would be my solution. Okay, moving on to determinants. We're going to go ahead and do number 12 on the review. Okay, we learned we always start in the top left-hand corner and multiply it across. So I'm actually going to write k times 3 minus 6k. I just don't want to make any dumb mistakes. Mr. Determinfish says, subtract, baby. And then I have negative 3k times 2k minus 1. So now I can go ahead and multiply these together. So I'm going to distribute that k. So I have 3k minus 6k squared. Here, when I distribute the negative 3k, I get negative 6k squared plus 3k. Now we have a minus again, so I actually have 3k minus 6k squared plus 6k squared minus 3k, and we end up getting 0. Okay, so this was a lot of work, but all of our like terms canceled out. Solving by Cramer's rule. So first thing I want to check for, are our equations in standard form? And in this case they are. So I'm going to start with determinant D. We know determinant D, my first column are our x coefficients. So I'm going to have 6 and 2. My second column are the y coefficients. So I have negative 3 and negative 1. So as I go through this, 6 times negative 1 is negative 6. Mr. Determinfish says, subtract, baby. Negative 3 times 2 is negative 6. So I end up getting 0. Now, just a reminder, when we get 0, we know we either have a solution that is an infinite number of solutions or no solution. So we're going to look back at our original equations. Okay, we said if I can multiply one equation by a constant and get the exact same equation, that means that they are the same. So I'm going to multiply this by 3 and see what happens. 6x minus 3y equals 9. Notice how they are exactly the same, so my solution would be all the ordered pairs on the line, and then I can write either of those two equations. It does not matter. Now, just kind of a side note, this is all we would need to do for this problem. However, if it said d sub x, remember this x means that I replace the x column with my constants. So I would have done 9, 3, negative 3, negative 1. If it had asked us to do d sub y, I would have replaced my y column with the constants. So that would have been 9, 3, 6, 2. In this particular problem, I don't need to do any of those. I have my answer right here, but I just wanted to review in case we forgot how to evaluate determinants. Our final solution most of the time is d sub x divided by d sub y divided by d. Okay, I want to go through a problem like this because it's actually the easiest problem we're going to see, but for some reason we psych ourselves out. So it tells us to write a system with 2 variables and 2 equations. So what that means for me is I know I do not have inequalities because it says equations, and I need to have 2 variables, so I need to have x and y in both. And it has 1, 3 as the only solution. That means that I'm not writing the same line twice because 1, 3 is our only solution. So the way that I'm going to do this, I think it's easiest if we write these in standard form, but it doesn't matter. I'm just going to write a combination of x and y's. For example, x plus y. Now, if I knew that 1, 3 is my solution, I know when I substitute in for x and y, whatever my answer is should be our constant. So in this case, 1 plus 3 is equal to 4. My second equation might be something like 2x minus y. When I substitute 1, 3, and I would get 2 minus 3, which is negative 1. So this would be an example of a correct answer. There are numerous correct answers that I would accept. The key thing is that I need to double check when I write my system does 1, 3 work? So what always works for me, I make up the x and y, substitute in, and that's how I figure out what my constant should be. And last but not least, we are ending with one of our favorites, a word problem. So first of all, I know x is going to be the airspeed, and y is going to be our wind speed. As soon as I see it's one of these distance problems, I'm going to go ahead and draw out my chart. So here's my chart, and I know I'm going there and I'm going back. I have my rate times my time equals my distance. So on the way there, it says we are going against a given headwind. So that would be x minus y. Then it tells me it can fly in 10 hours and 48 minutes. So our time needs to be consistent. So I'm going to think of this as 10 and 48 over 60. Now, I know I personally hate mixed numbers. I can actually simplify this, and it becomes 10.8. So I know my distance is 10.8 times x minus y. That's going to give me an equation of 10.8 times x minus y equals 6750. Okay, my second equation is going to come from this information, and it tells me flying back with the same wind blowing. So this time it's helping me out. It's making me go faster, so I'm going to do x plus y. It tells me it takes 10 hours. So my distance is 10 times x plus y, and I'm going to set that equal to 6750. Now, to make my life a little bit easier, I'm going to divide both of these by 10.8. And I get x minus y equals 625. When I divide everything in that second equation by 10, I get x plus y equals 675. I'm going to use linear combination here because my y's are already opposites. So I get 2x equals 1300. So x is 650. So I know right away the airspeed is 650 kilometers per hour. Now, to find my y value, I need to substitute in. So I would do 650 plus y equals 675. So y is equal to 25. So 25 kilometers per hour is the wind speed. Okay, so this was a quick overview. Remember, when we have parallel lines or when we use algebraic methods and we get a statement that is not true, like 5 equals 12, that means we have no solution. If we have the same line, we would see that when we graph it, or if we're using an algebraic method, we would get like 5 equals 5, and that's when we would get this solution, all the ordered pairs on the line, and then write the equation of the line. So keep studying. Good luck. Hopefully this just reinforces all the knowledge you already have.